Hi, welcome to EPG Pathshala. I am Prithvik Mishra, a research scholar at IIIT Hyderabad. I am going to talk about introduction to chunking and shallow parsing, which has been written by me and Professor Vidya-mitra Sharma. I am going to give you a brief introduction of what a chunk is. Chunks have several definitions according to different languages. So this came into existence. English chunking came into existence in 1991 when Abney proposed idea of chunks. Previously, there were the notions of phrases and generative grammars. You probably know about phrases, the concept of generative grammar proposed by Noam Chomsky, and the famous examples colorless green ideas sleep furiously. So chunks, according to Abney, were the collection of words or a single word containing a head word. There are several interpretations of chunks, which dates back to famous Sanskrit grammarian called Panini. Panini defined chunk as a minimal, non-recursive phrase containing a single head word. So we are going to discuss in the next about what chunking really means, what are the different kinds of chunks which are available in different languages. We are going to focus mostly on English and some examples in Indian languages, and techniques of chunking, and I will also brief upon what shallow parsing means. Then shallow parsing, the technique used in shallow parsing, and what is shallow parsing composed of, and the issues with shallow parsing, and we will conclude in this way. What is a chunk? In the introduction, we talked about what chunking is. Then I am going to explain what really a chunk is. A chunk is a single word or a collection of multiple words forming a constituent. I am going to explain what is a constituent in the next slides. So, according to Abney's definition, a chunk is a single content word which is surrounded by multiple function words. The Abney's definition was a single content word surrounded by a constellation of function words. I will explain what kind of function words comes in a chunk, and in Sanskrit grammar, Panini gave this definition as a chunk is a minimal, non-recursive phrase which describes the partial structure of a sentence and consists of words which are highly correlated. What is chunking? We talked about chunks. Then what is the correlation between chunk and chunking? In simple term, chunking can be defined as the process of identification of chunks. Chunks can be of multiple types. In English, the basic motivation of Abney's work was to identify minimal noun chunks, he called the term base NP. There were multiple experiments where researchers used minimal rules to identify NPs, and they reported high accuracy as well as identification of the NP along with all the words inside the NP. So here is a small example which is also quoted from from the Abney's reference. Like, he reckons the current account deficit will narrow to only $1.8 billion in September. So in this example we can see the different kinds of chunks which are demarcated by square brackets. So each of the words or collection of words constitute a chunk. Then we will, in the coming slides, we will discuss how chunks can be useful in different NLP applications and how chunking leads to a higher and better representation of sentences and all. Need for chunking. Parsing generally refers to the process of representation of a sentence using its syntactic and semantic features. Full parsing is often very expensive and less robust. We'll discuss like what full parsing is in the coming slides, and chunking in a way does partial parsing. It doesn't do the complete parsing in such. So chunking identifies individual chunks, then the individual chunks constitute of words which are highly correlated. So chunking in some way or the other can be designed in specific languages, can be designed by just introducing a grammar which will be able to take care of different kind of chunks. As we all know, English is a fixed word order language. It is easier to design a chunker for English, which indeed finds different kind of chunks. In this example, take an example. I begin with an intuition. When I read a sentence, I read it a chunk at a time. This example is a different kind of notion of chunk altogether. So another example I will give, like, I saw a monkey eating bananas. This is a very famous example where the question remains, who was eating the bananas? Whether the bananas were eaten by me or bananas were eaten by the monkey. So in this case, this sentence is an example of prepositional phrases. So in this case, there can be multiple kinds of attachment which are possible in this sentence. So a monkey eating bananas can be a clause, as well as I eating bananas can also be a clause. As we already pointed out in the previous slide, that chunking becomes easier for fixed word order languages. But what about chunking in case of free word order languages, like Indian languages or Turkish or some African languages? So in free word order languages, it's highly difficult to design chunks or grammars which will capture the position, because in free word order languages the words can appear at any position. So how someone intends to capture it. So if we come up with a rule to find out if the rules are specific to a position, then the rules will go for a toss if applied on a free word order language. Take an example of Hindi. One very small example is मैं घर जा रहा हूँ. So this sentence can also be told as घर मैं जा रहा हूँ. So I substituted मैं and घर. Still the meaning was understood. In most of the Indo-Aryan languages like Hindi, Punjabi, Marathi, most of the nouns are preceded by vibhakti. मैं घर पे बैठा हूँ. That पे follows घर. So घर पे usually constitute a chunk. So pe is a post position. Normally in Hindi and all Indian languages, post positions are followed. The nouns are followed by post positions. Similarly, मैं घर पे बैठा हूँ. Who is a auxiliary verb, which is following the main verb बैठा. So we are not going too much into details into what kind of morphology, how morphologies, different morphological patterns are realized in different languages. We are just trying to say like different kind of categories can follow main verbs or main constituents in a chunk. So in Dravidian languages like Telugu, Malayalam, Tamil, there are post positions. After English we are going to talk about chunking in free word order languages. Indian languages are free word ordered. Designing a comprehensive grammar for Indian languages is highly difficult. So if rules are designed specific to a position, like many chunking grammar rules are defined for English, is going to be a Herculean task. Mostly Indian languages are of two major families: Indo-Aryan languages and Dravidian languages. Indo-Aryan languages, the most spoken language in Indo-Aryan language family is Hindi. Take a small example of Hindi. मैं घर पे बैठा हूँ. So in this example, घर is being followed by the post position पे. So घर पे constitute a chunk. Similarly, बैठा हूँ also constitute a single chunk. Here we are going to focus what is there inside a chunk. So घर पे the main content word is घर, and which is denoted as the head word, which is being followed by a function word or a post position. Similarly, in case of a verb group, the main verb is normally associated with or is being surrounded with the auxiliary verbs. In Hindi, mostly the surrounding words come after the main verb. So in this case, बैठा is the main verb and who is the auxiliary verb. So when talking about Dravidian languages do not have they do not frequently use post positions and auxiliary verbs. All the information, all the morphological information like the vibhakti markers, the the tense aspect modality information is already encoded within the words. So, according to Paninian Karaka theory, the chunks are local word groups which are highly correlated. So in the coming slides we are going to see like the correlation cannot be tampered with. If the words inside a chunk are fixed order, the chunks are not fixed order in free order language, but the position of the words inside a chunk is fixed. We are going to see this aspect in the next slides. We are going to take one example of chunking in Hindi. One example is सभी बच्चे किताब पढ़ते हैं. The corresponding English translation of each chunk is given here also. All children books read. The gloss is all children read books. As we can see from these examples that Hindi and English are structurally different. English follows SVO kind of structure in sentences, but Hindi and most of the Indian languages follow SOV. So here in this case we can see that the main focus is always the head word, and in the above examples the head words are marked in bold. Constituents. We are going to talk about constituents. This is not a detailed explanation of constituents and identification of constituents. This is more about constituents as a whole and what are the effects in shallow parsing. So constituents, similar to chunks, consists of one or more words which act as a single phrase or a single unit. So constituents in a sentence can move around, but the words inside a constituents, when tinkered with, make the sentences ungrammatical. Here is a small example here. So in the sentence, on Sunday morning a big rally was held in the stadium. So if the constituents are moved around, the sentence is still grammatical and it conveys the same meaning as the previous sentence. Like a big rally was held in the stadium on Sunday morning. Both the sentences convey the same meaning, but the constituents are in different order. So when I told in the previous slide, if the individual words are moved around from the constituents, then it makes the sentences ungrammatical. So as we have talked about much about chunks and all, Sunday morning is a whole chunk. If you take morning out of Sunday and make a sentence like here, on Sunday a big rally was held in the stadium morning. So this sentence is highly ungrammatical. So we can see that here, if we are talking about only identifying the noun chunk, Sunday morning, big rally, the stadium, all three in this sentence are noun chunks. If you tinker the words inside the chunks, they are going to make the formed sentence ungrammatical. I am going to talk about the modeling part of identification of constituents. So mostly in English, constituents can be easily identified using context-free grammar. Context-free grammar usually consists of a lot of rewrite rules whose each rule's form is shown in the slide. So A goes to B, where A is a non-terminal and B usually refers to a string containing terminals and non-terminals. I am not going deep into the design of the rules, like what are the specifics of terminals, what are the non-terminals, and what is an automata, all kind of things which can be taken up seeing the reference material. So when we are talking about natural languages, non-terminals normally refer to the phrasal categories or the lexical categories, like the POS tags. Phrasal category means the phrase tags, like normally the noun chunks or noun constituents are labeled as noun phrase, or in short NP. Similarly, verb groups are referred to as VP or verb phrase. So terminals normally refer to the constituent words in the sentence, like they are not any abstract quantity, they are the words which are present in the sentence. We are going to take a small example of CFG. So this example, John went to the market. The CFG, the below CFG is able to parse this whole sentence. Here when I use the term parse tells me that using this grammar, this sentence can be formed, or according to this grammar, this sentence is an acceptable string. The automata theory and context-free grammar have been popular from long back, and Noam Chomsky's generative grammar's definition made it more popular in case of text processing. So in this case, when I am talking about the rules, like you can see that S goes to NPVP. So I am trying to identify the structure within a sentence, like NP. So in this case, I am trying to find out what are the constituents and which words will form a group. So in this case, there are different constituents or constituent groups, like NP refers to the noun phrase, VP refers to the verb phrase, PP refers to the prepositional phrase, and there are some POS tags. DT normally refers to determiner, NN is common noun, NNP is the proper noun. So this is a very small example of parsing through a CFG, cellular parsing. We have already talked about constituents identification, and how constituents can be identified easily with context-free grammars. So we are one of the main goal of this module was also to have a brief introduction about cellular parsing. Cellular parsing, all the contents which are already explained comes under cellular parsing. Cellular parsing consists of three major processes. One is tokenization, one is POS tagging, one is chunking. Several techniques are used for the individual processes. So I am going to give what are the techniques which are widely used for all these three processes involved in cellular parsing. Tokenization is the process of identification of words inside a sentence. So tokenization is usually done using regular expressions. POS tagging and chunking uses statistical models. We have till now only talked about rule-based systems and grammars, where we needed to design lot of rules which captured the structures of a sentence. So statistical models, I'm only going to tell a few names, not going to explain in detail what individual statistical models do. So the popular machine learning techniques which are followed for POS tagging and chunking are maximum entropy model, conditional random fields, hidden Markov models, and most popularly nowadays neural networks and recurrent neural networks. For each of these methods, the words and their features are presented as samples. So in case of POS tagging, the suffixes, prefixes, the root words, the length of a word can act as a feature. So all these statistical model try to find out similar kind of patterns in similar words when presented as a sample, which is a collection of feature. In POS tagging, neighboring words also act as a feature for predicting the POS tag. In chunking is highly dependent on POS tagging. As we saw in the CFG example, we saw that the chunks are made out of the individual lexical categories or POS tags. So context words and their POS tags play a very vital role in chunks. So as we can see as I explained in POS tagging's feature are slightly different from the features used in chunking. Chunking usually uses the word itself and its POS tag as a feature. And using only those features, systems reported very good accuracy. So the modeling how POS tagging and chunking is done. POS tagging and chunking are usually modeled as a sequence learning task. So given a sequence of words, usually we need to predict the POS tag sequence. So here the word sequence is a place where you needed to pay your attention to. So in these models, usually statistical models operate in two phases. One is training, one is testing. So training phase is associated with a large corpus of words to learn patterns from the data. And testing phase use the trained model to predict the tags like POS tags or chunk tags of the unlabeled data. Here slide 14 shows the parsing pipeline used in a shallow parsing. So given an input sentence, it goes through the tokenization phase. After the tokenization, when the words are identified, sequence of words are identified, it goes to POS tag. POS tag predicts the POS tags of individual words or the whole sequence, and then the POS tag sequence is passed onto the chunking module. Then chunking module gives us the POS tag and chunk tagged output. So in this case, we saw that this is a pipeline approach. So in the pipeline approach, one major problem is when one module makes a mistake, it gets propagated to the next module. So in pipelined approaches, the propagation of errors do happen. So this is usually called in parsing community as error propagation. So error usually occurs if less frequent or unseen words appear in test data. Appearance of errors can be due to multiple reasons, but I am going to talk only about the less frequent ones, and the other one where the annotation is slightly ambiguous. So when you are using an annotated corpus has to go through a round of validation process. So multiple validation processes ensure that the quality of annotation is good. In this module, we talked about chunking and shallow parsing. Shallow parsing constituted of especially three processes: tokenization, PO stacking, and chunking. And we talked about the pipeline of shallow parsing, the issues involved with shallow parsing, and this all gives you a very brief introduction about shallow parsing and parsing as a whole.